Hello everyone, this side Astha Goswami, and today I am starting one new topic which is a starting point of the dispersion from the spread of the value, which is range which is denoted by R. So let's study. It is a difference between the largest and the smallest value of the variable in the series. Let's suppose there is a series, okay, and in the series the number is 10, 2, 5, 6, 8. So the largest value is what? Largest value is 10, and the smallest value is what? Smallest value is 2. So in the series, when you observe, so there is the largest value and smallest value. So first pick the largest value and the smallest value, and then whatever the difference between the largest value and the smallest value you got, this is called the range. When you subtract 10 from the 2, so what you get? You get 2. So 2 is the range. So this is the difference of the number, like this is the maximum distance of the difference of the number, and any numbers like 3, 4 and other observations will be under the 8 as a range. So 8 is the highest degree of the range, and now if you are taking any other number, so it is under the 8. So where L is the largest value of the variable and S is the smallest value of the variable. So range can be calculated in absolute and relative sense. So from now, like a measure of dispersion, we will study in the two approach. First approach is absolute value and the second approach is relative value. So in the absolute approach, there is a unit, but to calculate the dispersion, we don't need unit to calculate the questions. We have to calculate without unit, and to remove the unit there is one more formula, and which is called the relative sense or coefficient sense, where the value is divided. So thus the absolute measure of R is L minus S. So to calculate, in order to calculate the absolute value, we just need to get the difference between the two values. But to calculate the relative value, what we need to do is relative measure of R, coefficient of R, which is L minus S and L plus S. So it is what? It is the largest value which is added to the smallest value. So first we have to write the formula of the absolute value, and in the fraction, in the denominator, you have to write to change the you have to write the same formula, but only you have to do is to change the formula. Now there is a determinations of the range. So there are so many series like marks 12, 15, 32, 25, 17 and 36. So as we have studied already that there are so many kind of series like individual series, discrete series and continuous series. So now in the determinations of the range, when we are determining the range, so we will make the questions according to the series, like in the individual series, a discrete series and continuous series. So here this question is the individual series because there is an absence of frequency. So as we can see that this is a individual series. So first we will calculate the absolute measure of the R, which is L minus N, and the largest value is what? So when you are observing, so largest value is 36. So we have written 36, and the smallest value, which is the smallest value? 12 is the smallest value. So in the smallest value I have written 12. So by taking the difference, I get what? I get 24. So 24 is the difference. but because it is an absolute value, so unit will be applied, so 24 marks. Then we have relative measure of R, which is L minus S divided by L plus S. So L minus S or L plus S, it is a relative value where only sign have changed. So we have to write the same thing, just the sign have changed. So while subtracting we get the same answer 24, but in the addition we add the largest value and the smallest value, which we get 48. And we are taking the difference or simplifying it, we get the 0.5 answer. Here we can observe that here we write marks, and in this we didn't write the marks. Why it is so? Because this is a coefficient or the relative measure where the marks will be not applied. So in order to take the dispersion, like how the value is dispersed, we don't need the marks or unit, we just need the dispersion. So if you are taking a difference in the normal sense also, if you think, then if you are taking the numbers are there and you just want to find the difference, so do you really want to have a unit? You just simply calculate the difference. So to have a logical thing, or in the mathematics also, you just need the difference, you don't need the unit. So if it is a unit, then it itself a answer, but we don't need an answer, we just need a difference. So here the unit is not applied, which is a real sense of the measuring the dispersion. Then we have a discrete series. So discrete series is marks 5, 10, 15, 20, 25, and the frequency is 2, 4, 10, 15, 5. So here is 5, 2, 10, 4, 15, 20, 10, 20, 15, 25, 5. So what is the here the frequency is added, and this is why this is called the discrete series. It is similar to the individual series, but in the individual series there is the absence of frequency. So here the frequencies is there. So it is not in a range, it's like 10 to 20 or something like that. So it is a discrete series where the individual observations is there as well as in frequencies are there. So absolute measure of the R is L minus S, which is 25 minus 5, and we get the 20 marks. So here we can see that in the range, even the frequencies is there, but there is a no work of the frequencies. The important rule is the marks. So when we are saying that the smallest value is 5 and the smallest value is 5, or here the largest value is 20, so here there is a no work of the frequencies. Unlike in the mode where there is a no work of the x um, numbers of observations and the frequencies matters a lot, but here frequencies have no work, there is only a work of the x observation. So we have observed what is the largest and the smallest value, then we subtract the value and we got 20 marks. So because it is a absolute measure, so unit will be applied. Then coefficient or the relative value of the R, where L minus S have a fractions with L plus S. So when we are subtracting it, what we get? We get 20 by 30. Okay. So in the 20 by 30, where when we are calculating it, simplifying it, here the 0 will be cancelled, and when we are into the when you are doing the divide from 3 to 2, then 0.67 will be the answer. Here there is no unit is there. Then we have a continuous series. So here the marks is 5, 10, 2, 5, 2, the 10 to 15, 5, 15 to 20, and 7 frequencies, 20 to 25, 5. So here we can see that no absolute value in the x observation is there. There is a range 5 to 10. So as we can see that this is a continuous series. So here it is very important to calculate the mid value. Okay, so here it is not written, but you have to calculate the mid value. So not mid value. So here you can see that in the continuous series it is already mentioned that the smallest value is in the beginning and the largest value is at the end. So here there is a 5 and 30. You can also take the mid values, it is the same, but even it can be measured by the question also. So the smallest value is 5 and the largest value is 30. So in the largest value we have written 30 and the 5, and when we take a difference, so this is a 25 will be the answer. Coefficient of the r is l minus s, l plus s, 30 minus 5, 30 plus 5, which is 25 by 35, and in the fraction what we get 0.71. So in the continuous series, so as the inclusive series has to be converted into an exclusive series in order to find the range. So if in the continuous series, if the series is in the inclusive, I mean in the inclusive series there is 5 to 9, then it starts from 10 to 15, then it starts from 16. So where this value is not repeated, like 10 is repeated, then 15 is repeated, that means in the first series 10 is not taken, then the second series 10 is taken. So it is the exclusive series where either upper limit or lower limit, upper limit or lower limit, so it depends on the question, is excluded. But in the inclusive series the both observation is have taken the value, and the when you move to the second observation, then the repetition is not there. When the repetition is there, then it is an exclusive series where in one observation it is included and in the other observation it is not included. Then the continuous series and exclusive series has to be converted into the exclusive series in order to find the range. Then we have merits of the range. So it is easy to understand and simple to calculate. So the calculation is very very layman terms, anyone can calculate, and the process is very simple. So it provides a quick picture to the variability of the series. So when the calculation is very easy, so we get the answer and we have the basic idea about the deviations, like measure of dispersion. So it gives a very quick picture and it gives a broad picture of the dispersion of the data, and it also gives the broad picture, like how the data is dispersed. So it gives a broad picture, and it is rigidly defined measure of the dispersion. Proper formulas is there, and no matter which formula you will apply, you will get the same answer. Then what are the demerit? So it is not based on all the observations of the series. So as you can see that in the observations where we are taking the largest value 25 and smallest value 5, but in the between like 10, 15, 20, so we completely neglect this value. So the deviation is like if we are willing to calculate the deviations from all the series, so this method of calculating the deviation, which is range, fails to calculate. So it is not based on all the observation of the series. Range does not take into account the compositions of the series or the distributions of the item within the extreme value. So range does not take into account the compositions of the series of distributions of the item within the extreme values. So if there is an extreme value, so how it is diverted, and taking the distribution of all the items, like how each and every item is dispersed. So it just give a basic idea, but to get the detailed dispersion, like dispersion from each and every observations, so it is failed to give. It just give a basic idea. It is like an average where the all observations are calculated and then divided, like in the arithmetic mean. But even the average is calculating all the value. I think it is like a mode where the highest frequency, so mode will be like that. But unlike the mode, in the range, there is a deviations, but in order to calculate each and every deviations from the single value is not there. Okay, so it just give a simple basic idea that how the data is diverted, but it doesn't give the detailed idea. So range is affected by extreme value of the series, as we can see that it is taking a extreme value, large observation. So if in the series there is a 20, 30, and all of a sudden there is one observation which is 1000. Okay, so if we are subtracting from the largest value to the smallest value from 1000 to 10, so what we get? 990. But is there a dispersion? It is not a dispersion. Why it is so? Because 990 is not a dispersion. It is just one exceptional case of the 1000. But all the dispersion in the series, like 20 to 30, 30 to 40, maybe it will be dispersed only to up to 40 or 50, and rest of the dispersion is useless. So it is affected by the largest value. So even the in the formula also the largest value is considered, and if the largest value is differ from the other observation, then the value we get is affected by the largest value, and error could be there. Then range can be calculated in a open-ended. Range cannot be calculated in the open-ended series. So as we can see that here also in the continuous series, here it written key first you need to make the series exclusive rather than inclusive, or first we have to get to know that the series should be in the close ended. So here in the close ended we have the in the first observation lower limit and the last observation upper limit. But when it is open ended, then the both the values absent, then how we will calculate the range? So the range cannot be calculated in an open ended series. Okay, so range is, and the fifth one is range is only a starting point in the measurement of the variations, and it cannot be used effectively in further statistical analysis. So as we can see, the formulas is very basic, but when the calculation is simple, it is not only in the range, but generally when the calculation is very simple, then it have so many loopholes and drawbacks, and which fails to the further statistical analysis. So similarly in the range also, there we can start a point, we can initiate a point, we can create the picture, but the formula is so basic that if you are looking for the detailed deviation or further statistical analysis, so it is very hard to calculate it. So range is only a starting point in the measurement of the variation, and it cannot be used effectively in the further statistical analysis. Then we will move to the second topic, which is quantile deviation. So this is also a part of the deviations which is taken by the directly the observation, rather than taking first the average and then calculate the that this average is how much deviated from the others. So here we can see that this is the dispersion from the spread of the values. It is also one of the way to calculate the dispersion if you are willing to calculate it directly from the values. So in interquartile range, which is also we can say that IQR. So interquartile range is the difference between the value of the upper and the lower quartile in the series. So IQR measures the variability of the series in the central 50% limit. Thus, absolute measure of IQR is Q3 minus Q1. Relative measure of IQR or coefficient measure of IQR is Q3 minus Q1, Q3 plus Q1. So, interquartile range IQR is the difference between the value of the upper and the lower quartile in the series. So, have you know that how to calculate the quartiles? So to understand this topic, first we will get to know about the quartile. So wait a minute. Okay, so to understand the quartile, first we have to understand the concept of the quartile. I mean, for if you are studying the quantile deviation, so when you are studying, so first you have to ensure that you have know the concept of the quartile, and then if you know the concept of the quartile, so it is very easy to understand the quartile deviation, because it is just similar to the range. So first we need to understand the concept of the quartile. So distributions can be divided into the several part. Median, so if the distribution is divided into two equal part, the central value is called median. So when the distribution is divided into two equal part, so the central value is called the median. Okay, so as we have already seen that median is like n by 2, whatever the value, so we generally take the mid value, okay, the half value. So in the median we arrange the series into the ascending or the descending order. So whether you are taking the ascending or the descending, the middle value will be the middle value, and we take the middle value and calculate it. So the half, when you divide the 2 with the middle value, so we get the, not the divide, number of the observation is divided by the 2. So generally we get the number of items which is generally in the middle, and whatever the value which is written in the middle, so this is called the median. So if the distribution is divided into the two equal parts, the central value is called median. Then we have quartile. So if the dispersion is divided into four equal parts, then there are three quartiles value called lower quartile, middle quartile and upper quartile, Q3. So if the distribution is divided into four equal parts, then there are three quartile value called lower quartile, middle quartile and Q2 and upper quartile. So to have a visual representations, I'm gonna show you that how quartile look like. Okay, so it is like, suppose there is a line which is a number of observations, okay, like x1, x2, x3, x4, okay. Then quartile is and you have said that this is a quartile value. Quartile is what? Quartile give a sense, like then septile, octile we will study further also, but quartile is for 4. Okay, triplet, quarter, so quartile is 4. So when the number of observation, suppose this line is the number of observation, is distributed, okay, it is distributed in the and the distribution is of the equal part. It is not that unequal distribution is there. When the number of observation is distributed equally into the number of whatever it is given. In the median there is 2, division of 2. So where the 2 equal part, okay, so in the median this is simple that observation is divided into 2 equal part. Okay, so this is the 50%, this is the 50%. But in the quantile, which is 4, the distribution, the line will be in the median, there will be the 1 line, but in the quartile there would be the 4 line. Okay, like 1 3 line. Okay, 1 2 1 2 as we have given also. Okay, yeah, now I'm getting, and 3. Okay, so this is left, so just don't consider it. So this is a value of median. Median is written like ME. Okay, so in the median and in the quartile, when you say, so this is the Q2. So Q2 and median both are the same. Here it is written Q1 and here it is Q3. Okay, so here is Q1, Q2, Q3. So here the line is what? 1 2 3 4. So it divides what? Q1, Q2, 3, Q3. So in order to get the 4 part, we take the 3 line. Okay, so it is not only the quartile, whatever you are getting, like 5, okay, like 5 6 7, so just subtract 1, subtract 1, subtract 1. So what you get? 4 5 6. Okay, so if you want to have 5 part, then you will draw 4 line. If you want to have 6 part, then you will draw 5 line. If you want to have 7 part, then you draw 6 lines. So it is depend on the level of part. And like for 4, if you want 4 part, there is a quartile. If you want 5 part, there is a quantiles, which is have written that this is for the 5 equal part, and this all are divided into equal parts. Okay, it is not like this is unequal, this is unequal. All the divisions are the equal. The median 2 equal part. This is and in the quartile it is Q2 written. Okay, so for the septile, what we will do? This is Q2 in the quartile. Q4 is written, so here Q4 2. Okay, Q2 4. Okay, sorry, 3. Then in the middle value. Okay, in the Q2 it is Q2 and in the mean it is mean. Okay, then Q2 Q1, here Q4, Q5. So these are the equal part, and here and Q6. Okay, not Q6. 1 2 1 2 3 4 and here 5. Okay, so 1 2 3 4 5. 1 2 3 4 and 5. So there is a 5 equal parts. So to calculate in 5, so there is Q6. Okay, Q4 6, QU6, sorry, QU6. So here it is written. So first we will start with the median. So if the distribution is divided into two equal parts, the central value is called median. Then we have quartiles. So if the distribution is divided into four equal parts, then there are three quantile value called lower quartile Q1, middle quartile Q2, and upper quartile, as we can see in the graph also. And I also explained this thing through the help of the graph. So when you are seeing the graph, so you get the visual representation and then you link in the mind. So it is very easy to understand. Like we are giving the example. So here in the economics, when you find the lines complicated, so just relate with any day-to-day life examples, and if it is a graph, then first try to understand the graph and then give the explanation about it. So then it is very easy to have the visual representation and people get the informations, and it is very easy to understand. So try to understand each thing with the help of the graph, and it is also helpful in the exams also. Then quantile. So if the series is divided into 5 equal parts, then there are 4 quantile value, namely QU1, QU2, QU3 and QU4. Sorry for the mistake, I was confused, but for making the quantile you have to make to get the 5 part you have to make four lines. Okay, so 1 2 3 and 4, these are the four value. And to draw the quantile, QU is written, then QU2 is written, then QU3 is written, then QU4 is written. So what we get? We get the 5 part, 1 2 3 4 5. So we get the 5 part. So in order to get the 5 part, we will minus from the 1. So we get that how many division we have to make. So if you want to have 5 equal part, then you have to make 4 division, QU1, QU2, QU3, QU4. Okay, then we have septile. So if the distribution is divided into 7 equal part, then there are uh, 6 septiles value, namely S1, S2 up to X6. So to make the septile value, there is a line. Okay, and here in the line, so we have to make 7 equal part, right? So first we will make S6, S5, S4, S3, S2 and S1. So 7 values, 7 equal part we want to have, and 6 values. So we subtracted by 1. So what we want? We want 6 values. So from the 6 value we get 1 extra, which is 7. So not only the 7, it is applied to each and every quartile deviations. So here 1, 2, 3, 4, 5, 6, 7. 7 equal part is there, and 6 distribution, 6 quartile values S1, S2, S3, S4 and S5 is written. So septile value is denoted by S1, S2, S3. Then we have octile value 1 greater than 7, which is 8. So if the distribution is divided into 8 equal part and there are 7 octile value, namely O1, O2 to O7. So similarly, when you want 8 equal part, okay, so what we have to do? 8 minus 1, we get 7. So 7 distribution should be there, right? So when you are making the line, so here the 7 equal part is applied. So 1, 2, 3, 4, 5, 6 and 7. 7 should 7 is there, and it is denoted by O. Here O1, O2, O3. So we will denote with the O. So O1, okay, sorry, O1, O2, O3, O4, O5, O6, O7. Okay. Then we have 1, 2, 3, 4, 5, 6, 7, 8. 8 equal parts will be there. So this is called the octile values. Then dectile. So if the distribution is divided into 10 equal parts, then there are 9 dectile value, namely D1, D2 to D9. Dectile values is like 10 equal part. So when we subtract it, so we have to draw 9 equal parts, 9 divisions. So from the 9 division we get the 10 equal part. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So dectile is denoted by D. D1, D2, D3, D4, D5, D6, D7, D8 and D9. Let's calculate the value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here there is a 10 equal part. So this is a visual representation of the octile, that how the octiles is divided. Then at the last, not the least, this is the percentile. So percentile is a very widely used term, and even if you are aware of JEE NEET, so they called it ki I got this much percentile. So what is percentile? This is not similar to the percentage. So if the distribution is divided into 100 equal part, then there are 99% percentile value, namely P1, P2 to P9. Okay. So the percentile is like there is a number, or where this number is distributed. So let's suppose you have a 500 number of marks, so where this which is equally distributed, like you got the 356 marks. So here we will equally distributed, 5 marks here, 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 5 marks here. So it is just the division of the marks. In the percentage, what we do, the whole number of marks,
Okay, so whatever you got, then the whole number of marks, and when then we into by the 100, and then we get the percentage. But unlike in the percentage, whatever you got, it is just distributed to the equal part. So in the percentile, which is 100 equal, we need 100 equal part. And how many division we want? Just subtract with the 1. So we want 99 99 percentile division. Okay, so division is 99, that means 99 percentile is there. And how the percentile is denoted? So like P1, P2, P3, and so on. It is up to the P99 maximum values, and division should be 1, 2, 3 up to 100. Up to 100 there is a percentile value. So here's the percentile is divided. There are so many other percentile, but these are the important, and especially the quantile value. So as you have studied that there is a deviation range and quantile deviations, especially in the dispersion of the values. So in order to understand the quantile deviation, you have to know about the quantiles, so how it is calculated and their basics. So quantile values very must, and the other values is also there, but you have to focus on the quantile values, and other values is also applied, but quantile value is one of the major things. So be sure that your quantile values concept would be completely understandable, and the graph is in your mind. Okay, then we have determinations of the partition value. So this is what? It's a partition. You are dividing it. So determining the partition value will, I think this video is now extended too long, and to take this all the things in the one video is quite boring. So I will make the determination of the partition, like how the quantile values is calculated, and make you understand in the next video. So till then, stay tuned, be consistent in your studies, and hope you like it. So do share and subscribe to my channel, and hope, and we will meet in the next video. So take care till then, bye bye, and do wait for my next videos. Have a nice day.